Okay, welcome to my lecture, and in this video I am going to discuss about gear trains. So as all you know that in the previous lecture we have discussed about the introduction of gears, just like spur gears, bevel gears, helical gears, everything. And now I am going to discuss about gear trains. So what is a gear train? A gear train is nothing but a combination of gears used to transmit motion from one shaft to another. For example, if you want to transmit motion from one shaft to another, so we use gear trains. Now, it becomes necessary to transmit motion within a small space where we require large space reduction. For example, if you take a gearbox of a two-wheeler or a four-wheeler, within the smallest space, there is a large speed reduction going to take place. That is how, with the help of gear trains. Now that is point he has mentioned here. It becomes necessary when it is required to obtain large speed reduction within a small space. The following are the main types of gear trains. We have four categories. First one is simple gear train and compound gear train, reverter gear train, and the next one is planetary or epicyclic gear train. Now here I am going to discuss about simple gear train. Right, you can see this is the simple gear train here we have. Now if you observe the diagram, here we have 5 gears, 1, 2, 3, 4, 5. Now in order to identify simple gear train, we have 2 points to be remembered. First one is 2 external gears of a pair always move in opposite direction. For example, if you consider this pair, it is rotating in the anti-clockwise direction and this is rotating in the clockwise direction. And second case is all the odd numbered gears move in one direction. Odd number means it's like 1, 3, 5 will move in one direction, and even number will have one direction. These 2 and 4 are even numbers. So first gear, third gear, fifth gear, if you observe anti-clockwise rotation, this is also anti-clockwise and this is also anti-clockwise rotation. And if you take second and fourth, these two are rotating in the clockwise direction. So in order to identify simple gear train, we have to be very clear of these two conditions. First one is 2 external gears of a pair always move in opposite direction, and all odd numbers gears move in one direction, and even numbered gears move in the opposite direction, like this. So here one more thing you have to remember is, in simple gear train, one gear is fitted on one shaft and these two are in contact. And next one, coming to the speed ratio. So what is the speed ratio? See here, it is the ratio of speed of the driving shaft to that of the driven shaft. Means, for example, if you consider this driving shaft speed is N1 and driven shaft speed is N5, then we can write speed ratio is nothing but N1 by N5. And if we want to identify whether it is a positive value or negative value, we have some condition to remember here. So the speed ratio value, it is nothing but speed ratio. Speed ratio value is negative when input and output gears rotate in the opposite direction, and it is positive when input and output gears rotate in same direction. So for this particular diagram, you can see the input gear is rotating in the anti-clockwise direction and output gear is also rotating in the anti-clockwise direction. Means these two are having the same direction of rotation. So the gear train value will be here, it is positive. For example, if there is no fifth gear here and only 4 gears we have, so if you observe, this is rotating in the anti-clockwise direction and this is rotating in the clockwise direction. So the the speed ratio value will be positive, like this. Sorry, the speed ratio value is negative. Okay. And next one more thing we have to remember is the speed ratio. The reverse of speed ratio is known as train value. That is nothing but 1 by speed ratio. The reverse of speed ratio is known as train value, which is nothing but 1 by speed ratio. So we have a small derivation to find out speed ratio and train value here. So for that, let us assume capital T is the number of teeth on a gear and n is the speed of a gear in RPM. Let us assume T is the number of teeth on a gear and n is the speed of a gear in RPM. Right? So if you observe, we have 5 gears, 1, 2, 3, 4, 5, where n1 is the speed of this one, n2 is the speed of this one, n3 is the speed of third one, n4, n5, and like that. T1 is the number of teeth on first gear, T2, T3, T4, T5. Now we have a condition for that. So if you consider first gear and second gear, so we have a condition for gears 1 and 2. We have n2, that is speed of second gear, by n1, speed of first gear, is equal to T1 by T2. In the similar manner, if you consider second and third, then we can write n3 by n2 is equal to T2 by T3. And if you consider third and fourth, you can write n4 by n3 is equal to T3 by T4. And if you consider fourth and fifth, so for fourth and fifth gears, so we can write like this: n5 by n4 is equal to T4 by T5. So these are the equation for every pair of gears from gear numbers from 1 to 5. Right? Next, now how to get the train value? So multiplying R left hand sides and right hand side, then we are going to get like this. That is n2 by n1 into n3 by n2. This value into this value into this value into this, into n4 by n3 into n5 by n4. That is equal to, we are going to get T1 by T2 into T2 by T3 into T3 by T4 into T4 by T5. So I can write like this. So from this we can get n2 gets cancelled, n3 gets cancelled, n4 gets cancelled. Here also T2, T3, T4 and T4. So remaining values are n5 by n1 is equal to T1 by T5, which is known as train value. How can I say this train value? We know that speed ratio is equal to nothing but input by output. If you observe here, n1 is the speed of the input gear, n5 is the speed of the output gear. So here we have output by input. So this is opposite to the speed ratio. As we have discussed, this train value is opposite of speed ratio. So we can say simply n5 by n1 is equal to T1 by T5. So if you want to get speed ratio of simple gear train, then we can write n1 by n5 is equal to T5 by T1. Like this. Now if you observe the train value and speed ratio, here if you want to identify train value or speed ratio, the intermediate gears, that is gear 2, gear 3, gear 4 will not showing any effect, or those values are not present in these two formulas, so that whatever the size of the 2, 3, 4 gears and whatever the speed of the 2, 3, 4 gears, and whatever the number of teeth on 2, 3, 4 gears, they will not affect the either train value and speed ratio. So that gears 2, 3 and 4 are called idlers, means they are just idle gears. Okay, so with this I am going to stop this lecture. Thank you.